Good morning, everyone. I hope we're all doing well. We're going to start a new section. I believe it's going to be 2.4. Well, we're going to find out if I made a mistake. I think we're being recorded. I think as far as I know, it's 2.4. We wrapped up 2.3. Again, guys, if you need help with any of the MATLAB problems, exam problems, and you can always text me. Be very clear. Tell me the name of your course and section number, problem number, give me a screenshot. I'll be happy to incorporate it. Okay, let me look at my notes so that I can tell you exactly what it is that we are trying to do or we plan on doing today. Before I can do that. Okay, so remember a couple of days ago I said, you won't know what domain means, what range means. We're going to discuss it further in detail, and this is the section when we're going to do that. So today we will do some of that. So hopefully some of the old stuff that we just said, don't worry about it too much, will make a little more sense. Another important thing, guys, we are going to be using graphs today. We will be using a graphing calculator. So, which is kind of new. We haven't done that here in this class so far. So let's see. So according to my calculation, we're going to be doing 2.4. Okay. Now we're going to graph 2.4 is about graphing sine and cosine function. How are we going to graph? We're going to use Desmos. Okay. So we're going to go very slowly today. All right. So you're going to learn about Desmos. Why is Desmos better than your graphing calculator? Your graph. Go ahead. Anybody wants to talk to me? Just unmute yourself and say I have a question. All right, guys. I know it was probably you were talking to someone else. No problem, guys. So, guys, we are going to use Desmos because Desmos is free and it's in color and all those things. If you have an 84, you can use it, but most of my students use Desmos and you will be taking the exam online. So it's a good idea to be comfortable with Desmos. So let me show you. And I know we are being recorded. And just to let you know, sometimes I'm talking to the students. Some of my students watch it later. So I say things as if I'm talking to everybody, and I am. So you go to Google, you type in Desmos, Desmos, and you want graphing. Okay, you click that, and you're here. So let's say another important feature. Well, we're gonna let me just do it, then I'm gonna explain it to you. Y is equal to sine x. This is what you get when you type in y is equal to sine x. This is the graph of the sine function. Let's just stick to that. Now, when you're doing trig, your y-axis generally, x-axis, sorry, x-axis generally is in terms of pi. How do you fix that? Well, you go to this wrench symbol, okay? You want to fix the x-axis. You want it to go up by pi over 2, okay? How do you type pi over 2? You go to the keyboard and type in pi, okay? You go to the keyboard, which you can't see, type in pi, and then you divide it by 2. Well, that's fine. We're just going to take it, starts from 2 pi, negative 2 pi, the smallest side, and you can, of course, change it. And you go to 2 pi. You can choose 3 pi. I don't care. Again, how do we enter pi? Pi, not PIE, pi. Now, what step? Okay. Step is the gap between two consecutive marks on the x-axis. And I'm going to tell you what I mean in a second. Okay. So take a look at this, guys. Okay. For x-axis, I don't worry about the y-axis. Okay. Doesn't do a whole lot. So you can leave it alone. I'll tell you when we need to change it. We'll go over it. On the x-axis, I want the left-hand side to be negative 2 pi. Let's make it negative 3 pi. Okay. and the right-hand side to be positive 3 pi. You can choose 4 pi, negative 4 pi, positive 4 pi, negative 5 pi, positive 5 pi. That's up to you. I'm going to tell you what it is. This is important, guys. You want to have pi over 2 here. For step under x-axis, you always want to have pi over 2, almost always. I can't think of an exception where we would go for something else, okay? And radian is good, okay? Most of the things we do in graphing in trig will be in radian. And the moment you put pi here, computer understands that you're doing radian. Okay, good. Now take a look at this. Remember, guys, the step that we said is pi. Now, just to let you know, when I write here, I have to kind of take it somewhere else. I can't just write on the screen so easy. Let me see if I have a way of do. Well, I won't worry about that. I'm just going to take it to another place and show you what we mean by step. Okay, it's not a problem. One second. All right. So this, I just got this from there, right? Got this picture from my other screen. So this is what we mean by step. Okay. The two consecutive hatch mark is pi over 2 or 90 degrees away. So again, remember guys, I told you, you have to really understand pi is 180. So pi over 2 is 90. Let's write down a few of these here, okay? And you want to go back and forth, okay? You don't want to go back to your calculator and do all that. You really have to, it really has to be smooth. This is 90. I'm going to do it in the same text box. And this is pi 180. And on the other side, I'm going to just do 2. And this is going to be negative 90 and negative 180. Okay. Again, you have to kind of know it by heart. So what is this one? 3 pi over 2. If pi over 2 is 90, 3 pi over 2 will be 270. 90 times 3. What's 2 pi? That's 360. If pi is 180, 2 pi is going to be 180 times 2, so on and so forth. But these two are good enough for today. So this is this is the graph of the sine function. That's what we call it. So let me write down here on top what we're dealing with. We have a graph. So bear with me, guys. The stuff we're going to talk about today will take a little longer than usual. I won't keep you here, but if we don't wrap up something today, don't worry too much. We're going to wrap it up eventually. And you really want to get it, okay? You really want to get it. All right, so this is the graph. We got it from our little graphing calculator. Again, we want to make sure under step, it is, okay, great. This won't let me do that, but we're going to work on it. When you change the font, things move around a little bit, okay? That's what's going on, but we'll survive. Okay. Once again, negative pi over 2 is negative 90. Negative pi is negative 180. Pi over 2 is positive 90. And just pi all by itself is 180. We know that. And you can use these two to find everything else if you need to convert it to degree. Okay. So this is the graph of the sine function. That simply means when x is 0, the sine value is 0. When x is pi over 2, the sine value is 1. Your unit circle will tell you that. And the picture is showing the same thing. When x is pi, sine of pi is 0. That's what this is right here. When x is negative, sorry, 3 pi over 2, 3 pi over 2. I'm going to show you on a graphing calculator that the graph makes sense. When x is 3 pi over 2, it's going to be negative 1. So let's show you this bit, just the first bit, okay? So the calculator I use, sorry, It's all from Desmos, okay? All right, so this one. So I'm trying to convince you that this is a valid graph. So let's see what sine of 0 is. Sine of, I want to make sure it's in radian. Let's see. Give me 1 second. Sine of 0. I kind of forgot how to get to radian, but we're going to find out in a second. Okay, sine of 0. Let's see if it's 0. All right. Sine of pi over 2. Sine of pi over 2. Okay, so it's in degree. So how do we change it? Give me, oh, right here, right here. Awesome. I want everything in radian, guys. Okay. So again, guys, let me go over it. I like this computer Desmos stuff because when I do a calculation, you guys can see it. I would encourage you to use the same. So how did I convert from radian to pi? If you go here, your degree. If you hide degree, you're going to radian. You're going to get to radian. So take a look, guys. It's consistent with what we're getting here. And that certainly is a good sign. Sine of 0 is 0. Sine of pi over 2 is positive 1. And this is right here, which is positive 1. And let's try one more. The next one is sine of pi. Hopefully that's 0. Your calculator tells you it's 0. Your your unit circle will tell you it's 0. So that's a good thing. 0. What about positive 3 pi over 2? What should that be? Well, hopefully that'll be negative 1. Negative 1. Got it. What about 2 pi? Hopefully that's going to be 0. Okay. So this graph makes sense. All right. So at least the numbers work out. I can use the unit circle, but it's a little tedious. But let's just use our calculator, which we did. Now, it's important to see, guys, I'm going to go back to Desmos, that this curve goes on and on like a wave. Okay, it goes on and on like a wave. It does go through the 0 point, okay, and it goes like this. And this part of the curve is very, very important, okay? Why? Because everything else is a copy of this. Everything else is a copy of this. So keep that in mind. And this concept that, remember, we said sine function is periodic and it has a period of 2 pi. That simply means if you observe the function from 0 through pi, let me write down, let me draw a line. If you observe the function from 0 through pi, and let me change this thickness and color. Okay. You know everything about the function. You're going to just copy it on the left, copy it on the right, and you keep on going. It'll work fine. So an important question, guys, the sine function is periodic. It repeats itself after 2 pi. After every 2 pi, 0 through 2 pi is the main focus. And after that, on the left, on the right, it's just being repeated. All right, another important thing. The maximum value is positive 1 and the minimum value is negative 1. Okay, that's also important. So a couple of classes ago, we discussed domain and range. Domain, we said all the input values, okay, all the things you can input here. You can input any real number, anything. And so we're going to write it again. It's a little bit of a repetition. I'll be happy to pause in a minute and ask you if you have any questions. If you don't mind, I'm going to get rid of this. It's just a distraction. So guys, the domain of the sine function is all real numbers. So domain. Now, the best way to write domain is, guys, is write it like this. Okay. This is a way of saying all real numbers, negative infinity to positive infinity. In English, you can write all real numbers, okay? Depending on how your question, how your book will accept your answer. What is domain? All the things you can input X for X. X is that angle, and it can go left, counterclockwise. It'll be positive. It can go clockwise. It will be negative. It can circle around and go on and on. So it covers all real numbers. But the range is the output value. The range is very limited. The range of this function is only between -1 and +1. That's the range because it will never, this curve never goes above 1. Sorry, never goes above 1, never goes below -1. So the range and domain of the sine function are negative infinity to positive infinity is the domain. Range is -1 to +1. And you do want to put square brackets there. Your book will consider it incorrect. If you put parentheses, what's the difference between square bracket and open parenthesis? Square bracket includes -1, and this square bracket includes +1. And this kind of a bracket, open parenthesis, sometimes we call it, means negative infinity is not included. We generally don't include infinity because we think it's way beyond our comprehension. That's one way to see it. And the same thing here. So let me pause here a little bit, see if you want to ask any questions about domain and range and why we're calling the sine function periodic or anything else. Okay, guys, let's see if we can graph the cosine function. So let's keep sine function here, okay? And the Desmos software is a very good software, okay? I'll tell you why in a second. See, you can see multiple graphs. If you don't want to see it, play with it. You can just hide the sign. You don't want to see sign, just hide it. Click that little wave on the left-hand side, it'll be hidden. So look at how sine function and cosine function are related. Now, before we move on, guys, let me hide this for now. This is the cosine function. Let me take this picture and go to the place where I can write and kind of go over, excuse me, kind of go over something very similar to what we did before. All right? Tell you what I mean. So here, this is the graph of y is equal to cosine x. Okay, let me check a few points using my calculator. I mean, that's not a bad thing. Um, that's not a bad thing. So let's see. I know it's correct. I've used this software. It's a good software. So let's see what sine of 0 is. Sorry, cosine of 0. Sorry, guys. Cosine 0. Everything is in radian. I like it. It's 1. And hence this point, cosine of 0 is 1. Cosine of pi over 2 should be 0. Your unit circle will tell you the same thing. The graphing calculator will tell you the same thing. Cosine pi over 2. Okay, I'm in degree. That's not good. Now I'm in radian. Okay, right here. And that's what we expect. Cosine pi over 2 is 0 right here. Cosine pi over 2 is 0. What do you expect for cosine pi to be? I'm going to say -1. Your unit circle will show -1. Hopefully our calculator will show the same thing. Cosine pi -1. There we go. I'm not going to check anymore. You get the point. Now, interestingly enough, just like the cosine sine function, the cosine function is periodic as well. What's periodic? Periodic means after a certain point, it starts to repeat itself. What is that certain point? Same as before, 2 pi. Okay, take a look. This little picture is being repeated over and over and over again. So if you know about this, looks like a U to me, the letter U. If you know this, you know everything. On the left, it's the same. On the right, it's the same. I know you can't see enough, but you can go to Desmos and make it expand. I'll show you how to do it in a second. So let me write down the domain and range for the cosine function. Once again, domain is all the acceptable x values. Just like before, you can put anything, any negative number, any positive number, no problem. You got the domain. What's the range? Just like before, the range is square bracket -1 to 1. Why? Because sine cosine values, remember, sine is the cosine function is the x coordinate, and it's going to be on a unit circle. On a unit circle, the x coordinate will always range between -1 and +1. So it's just like the sine function. There is a difference. The sine curve goes through the origin. The cosine function does not. Okay, now let's see if we have any questions, guys. And while you're thinking about a question, I'm gonna grab my tea in a second, okay? I'll take me a second. All right, guys, I'm back. So what's going on here is we learned about the sine and cosine function, how they're similar, how they're different. Let's go back and compare the two. Look at both of them. Okay, the maximum, these peaks are called maximum values, these bottoms are called minimum values. They're always going to be between 1 and -1. By the way, look at this, 1 and -1. This is 1, this is -1. Now if you want to see more on the left and the right, you go here, wrench, and you can take the x-axis and make it 4 pi, -4 pi, and make it 4 pi. It'll show you a little more. Okay, and you can go back. And just a little bit about this, if you keep on pressing it, you can make one dotted. So you have to I like it solid. You can change the color. Let's say I want to change the sine curve to green. You can do all that. And this, you can hide it by clicking. If it's not hidden, you move your cursor onto this circle and keep it pressed. It'll give you some options so you can change the thickness and all that. We're not going to worry about it. So that's what we know about sine function and cosine function. Let me show you what we kind of did. We did graph. They're talking about all this. We did some of these on our calculators. We did for both. I'll show you really what I want you to understand. It's a slide from your book. All right, this is very, very important, guys. Okay, let me take this and go over here, and you really want to understand this. All right, the domain sine function, the first one we did. Okay, let me grab the graph. That might help. This is the graph. I'm going to make it a little smaller if you don't mind. Doesn't really matter. So, but what they're really saying here is that the domain and range we talked about 1 and 2. The sine function is odd. Let's talk about it, guys. Okay, it's a little tricky concept, guys. Remember when we said this is an odd function, this is an even function, but don't worry too much about it. What's an odd function? Okay, if you take, and bear with me a little bit here. Okay, I have two copies of this, okay? Let me see if I can. One is a little lighter, okay? The one on top is a little lighter. They're identical, right? If I move, I pin it at the origin. If I move it 180, it matches itself. That kind of a function is considered an odd function. This is called symmetric with regard to the origin. I'll show it again. If you take a function, make two copies, and move it half a circle around the center, and it matches itself, that function is called odd. I'm going to delete it. I'm going to say what's an odd function? Odd functions are symmetric with regard to the origin. I need a little bit of room here. Odd functions are symmetric with regard to the origin. That's what it means. WRT means with regard to symmetric. Did I spell it right? Symmetric odd functions are symmetric. I think I did with regard to the origin. Now, you have to understand what does it mean for something to be symmetric with regard to the origin? It simply means if you pin it at the origin, move the curve 180 degrees, it matches itself. Okay? It's a difficult concept, but we did show you, right? Take a look. I'll show you once again. Here is one on top. I'm going to move the one on top, 180, 90 degrees, 180, it matches. Perfectly matches. So that's an odd function. So let me get rid of this. Any questions about odd functions, guys? Any questions? They will ask you, is sine an odd function? Is cosine an even function? Sine is an odd function. And this table is something you don't want to blindly memorize it, but you do want to be familiar with it, and you do want to understand what every term means on this table. Okay. The sine function is periodic, and we kind of explained it. We said that after 2 pi, it kind of repeats. That's what they mean. And the period is 2 pi. So if you focus from 0 through 2 pi, you will be in good shape. That's what periodic means. Another thing that you guys kind of know, I would say more than kind of, you know very well, these are called x-intercepts. So where does the curve cross the x-axis? Here, 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 and here. And that's all they're saying. The y-intercept means where does the curve cross the y-axis? Only one place, right here. That's what they have here. Okay. The maximum value is 1. And where does it occur? Right here. Right. Let me get rid of this. Okay. Too many marks. So what about the next one? The maximum value, the peak, takes place here, here, and here. And of course, it goes on and on. Okay. After 2 pi, it'll be another peak. And the same thing, the minimum value. Let me get rid of this. The minimum value is the bottom, takes place here, takes place here, which would mean here, here. I think I can see one more here. And that's what these are. Okay, negative pi over 2, negative, the minimum value for sine function, negative pi over 2, positive 3 pi over 2, all those things are here. Okay. So these are all fine. They started with this, and then 3 pi over 2, then 7 pi over 2, then 11 pi over 2. You can't see it, but if you scroll on your Desmos, you will be able to see it. Okay? right here. 7 pi over 2, 11 pi over 2. All those things are there. So let's pause there a little bit. Okay, let's pause there a little bit. And we're going to kind of go over the same thing about the cosine function. There is a table like that about cosine function. You want to have these handy when you take the exam or do the homework problem. You want to have the unit circle handy, and you really have to understand. If you don't understand what's going on and you're thinking, oh, I have all the notes, you're going to mess up. Okay, so you want to understand. The good news is you have access to all sorts of things. I'm going to give you a couple of minutes. All right, guys. So, guys, it's going to kick me out in 10 minutes. So, why don't we jump out and come back really fast? All right. See you soon.